Class.
So we discussed about different type of interrupts and traps.
Okay. Elaborate on that.
Especially interrupt handling, input-output interrupts like when a user requests a certain action, the CPU uses the interrupt to access the session, then process it, then come back to the previous execution like that.
A little bit elaborate. Any other person who can elaborate on that? Srilada, Vaditya?
I didn't attend last class, sir.
If you don't attend the class, it's a responsibility to ask what has happened in the class. Don't you think it is a responsibility to ask what has happened in the previous class? Iba, Cleopatra? Iba? Iba, Cleopatra? Niranjana? 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 Iba said her mic is not working. What about Niranjana? Niranjana? Katula Shweta? Katula Shweta? So I planned those are not responding. I will just expel them from the class. That is what I have planned from this class. So if you call the name and if there is not any response from them, then we'll just remove them from the class. Niranjana, you are there? Niranjana. So removing her from the Niranjana from the meeting. Yes. Katula Shweta,
I'm here, sir.
now tell me what has happened in the last class. Niranjana. Not Katula Shweta, tell me.
We learned about interrupts, sir.
Huh?
Interrupts.
Okay. Interrupts what we discussed. What we discussed. Anshit. Anshit. Quickly summarize what we discussed in the last class.
Just about interrupt handling,
Huh?
input of interrupt handling.
So what happens when an interrupt occurs? Tell me that part.
Sir,
What happens when an interrupt occurs? Anvish.
Yes, sir.
Anvish, tell me what happened when an interrupt occurs. Anvish, you are there?
Yes, sir. Yes.
So tell me that.
I don't know, sir.
Kaushik Chiteri.
Yes, sir. Hello.
Kaushik Chiteri.
Yes, sir.
Tell me what happens when an interrupt occurs.
So when an interrupt occurs, the program which is being executed currently, it will stop its execution, and the control will go over to the interrupt service routine. From interrupt service routine, the control goes to the first instruction of the program that caused that interrupt, and after the execution is completed of that particular program which caused the interrupt, control is again transferred back to the previous program.
Okay, good job. So as I said, you please read the portions daily, otherwise it will be very, very difficult to get pass in operating system. And you know the main papers in computer science. So questions will be questions can be expected when you go for an interview, either in a software industry or in the UGC NET JRF examination. Questions will be damn sure from this operating system. So please pay proper attention. So in the last class where we stopped,
So synchronous and asynchronous.
With the diagram.
huh?
So you were supposed to explain that diagram of synchronous.
The diagram you have drawn, right? So before the theory part where you stopped,
So synchronous and asynchronous, sir. Exactly like IO completion in the following
no,
ways.
exactly the sentence you can replace. Say,
Hi, sir. Operating system indexes into input-output devices table to determine the device status and to
okay, good. So now I'm going to say or portray how this synchronous IO is different from the asynchronous IO. Just wait a couple of minutes. I will just open that. Can you able to see my screen?
Yes, sir.
Yes, sir.
Please write how the synchronized IO works and asynchronous IO works. Imagine that a thread or which is a process of the execution. In synchronous IO, what will happen? The process will stop its execution. It will go for the file input output. Once the interrupt job has been done, again it will resume the program which is under execution. Whereas in asynchronous IO, the process will not wait for the any interrupt. It will continue its operation parallelly along with the interrupt operation. Please draw this diagram. The very, very important difference between the synchronous and asynchronous IO. Please draw that.
Yes, sir. Done, sir.
A thread is nothing but a process or a program in under execution is known as a thread. Okay, so don't get confused with the new name called thread. You can write instead of thread program. Okay, instead of thread you can write this as program.
Answer.
Completed, sir.
We completed.
Yes, sir.
Yes, sir.
So now, please write role of. Okay, look at the diagram. On that day, we have seen the diagram, right? So please look into the diagram of this interrupt handling. Wait. Yeah, it's opening. 1 second, please wait. Wait. Please look into this diagram. Can you able to hear me?
Yes, sir.
Yes, sir.
Okay. So imagine that there are various IO devices, and in middle we have this interrupt controller, and third we have the CPU. So the first step will be that the occurrence of an interrupt, and that occurrence of an interrupt will be from any one of these IO devices, for example. So this occurrence of an interrupt on any one of these IO devices will hand over that to the interrupt controller, which will in turn handle the interrupt. This interrupt controller, what does it do? This interrupt controller will issue the interrupt to the CPU. That's the second step. See, the first step is the occurrence of an interrupt. This is the first step. And the occurrence of an interrupt will be reported to the interrupt controller. This interrupt controller is nothing but an hardware which will in turn transfer this interrupt to the CPU. Once the CPU receives the interrupt, like last class we discussed, it will just go to the starting address of the interrupt service routine. Okay, so CPU on receiving the interrupt, it will just act upon this interrupt. This is how the three steps how the interrupt will occurs that has been depicted in the form of a diagram. Please write the role of interrupt handler. What is the role of interrupt handler? We have the interrupt controller, right? So this is also called as interrupt handler. So we'll just discuss what is the role of this interrupt handler. Please write the role of interrupt handler. This interrupt controller is also known as interrupt handler. Please write it. The role of interrupt handler or controller. Can you able to hear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Finds out the source of interrupt generation. First point. Finds out the source of interrupt generation. Finds out the source of interrupt generation. Finds out the source of interrupt generation. Second step is that analyzes status. Analyzes status. Analyzes its status. Third step. Restart it when appropriate. Restart it when appropriate. Restart it when appropriate. Restart it when appropriate. Next operation. Restart it when appropriate. Next operation to be executed. Restart it when appropriate. Next operation which is to be executed. Last one, a return control. Return control to the interrupted process. Return control the interrupted process. Return control to the interrupted process. These are the role of interrupt handler. Okay. The first one is that it will find from where the interrupt has really occurred. So from which the interrupt has occurred, that will be finding the source. That is first step. Second step is that it will analyze what is the status of the interrupt. Okay. Third, it will restart it when appropriate next operation to be executed. Fourth step is that it will return the control to the interrupted process. Once the interrupt service routine has completed its execution, the control again has to be handed over to the program which has been halted in between its execution. So that returning of the control from the interrupt service routine again back to the program will also be taken care by this interrupt handler. Please write next step as interrupt vector table. Interrupt vector table. Interrupt generated from the devices. Interrupt generated by the devices will be handled by the interrupt controller. Will be handled by the interrupt controller. And this interrupt controller will pass this interrupt, and this interrupt controller will pass this interrupt to CPU. The interrupt controller will pass this interrupt to the CPU, and the interrupt controller will pass this input to the CPU. CPU then act upon this interrupt. CPU then act upon this interrupt. CPU then act upon this interrupt. CPU then act upon this interrupt and the interrupt service routine and the interrupt service routine and the interrupt service routine will execute its job, and the interrupt service routine will execute its job. Once the interrupt has done its job, once the interrupt has done its job, the control has to given back. The control has to given back. The control has to given back to the interrupted program. The control has to given back to the interrupted program. The control has to given back to the interrupted program. And this is taken care, and this is taken care, and this is taken care by the interrupt handler, and this is taken care by interrupt handler, and this is taken care by interrupt handler, and this is taken care by interrupt handler. After the completion of one interrupt cycle, you're all there with me?
Yes, sir.
After the completion of one interrupt cycle, after the completion of one interrupt cycle, the CPU, after the completion of one interrupt cycle, the CPU will check, the CPU will check if there any interrupt is pending. The CPU will check if there is any interrupt, is pending. If there is no interrupt, then the CPU will go on. If there is no interrupt, then the CPU will go on with, if there is no interrupt, then the CPU will go on with the next instruction. The CPU will go on with the next instruction. Then the CPU will go on with the next instruction in the halted program. The CPU will go on with the next instruction in the halted program. If there are any interrupt pending, the CPU will give priority. If there are any interrupt pending, the CPU will give priority. The CPU will give priority to the pending interrupt. The CPU will give priority to the pending interrupt, and the current program which was in execution, will be in the suspended mode. The current program which was in execution will be in suspended mode, and its status will be saved, once the interrupt is generated. Once the interrupt is generated, the CPU will act upon the interrupt. The CPU will act upon the interrupt, and it finds what kind of interrupt, is being generated, and it finds what kind of interrupt is being generated, and it finds what kind of interrupt is being generated, and finds out what is the number of interrupt generated, and it finds out what is the number, and it finds out what is the number of input generated. It means that each and every input will have a number it is generated. So CPU will also finds out what is the number of the input generated. You're all with me?
Yes, sir.
Yes, sir. The particular table in memory. There is a particular table in memory. There is a particular table in memory called as input interrupt vector table. There is a particular table in the memory called as interrupt vector table. There is a particular table in the memory. There is a particular table in the memory called as interrupt vector table. In bracket, you please write IVT. There is a particular table in the memory called as interrupt vector table.
What, sir?
IVT consists of, IVT means interrupt vector table, IVT consists of the interrupt number. IVT consists of the interrupt number and the address of the interrupt service routine. IVT consists of the interrupt number. IVT consists of the interrupt number and the address of the interrupt routine, and the address of interrupt routine which executes an occurrence of the interrupt, This interrupt routine will do the necessary. This interrupt routine will do the necessary. This interrupt routine will do the necessary. This interrupt routine will do the necessary for the interrupt. This interrupt routine will do the necessary for the interrupt which occurred. This interrupt routine will do the necessary for the interrupt which occurred and after the execution of the interrupt routine, and after the execution of interrupt routine, and after the execution of the interrupt routine, the control will be returned. The control will be returned back to the main program. The control will be returned back to the main program, which was passed, and it will be resumed, So this interrupt vector table plays a very, very important role. The interrupt vector table, what does it contain? Two things it will contain. The interrupt vector table will contain the interrupt number, and also it will contain the address, the starting address of the interrupt service routine. These two things the interrupt vector table contains. So initially I will again repeat a story which we discussed in the last class. Initially the CPU will execute a program, and when there is an occurrence of an interrupt, what will happen? The interrupt controller, interrupt handler, what does it do? It intimates the CPU that the control will be handed over to the interrupt handler. The interrupt handler, what does it do? It will try to locate this interrupt vector table. In between that, CPU, before acting on the interrupt, CPU job is to find what is the kind of interrupt is being generated and what is the particular number of interrupt which is generated. So there are some static numbers which is associated with each and every interrupt. So the job of the CPU is to identify what kind of interrupt has occurred and what is the number that is assigned to the interrupt which has occurred. That job will be done by the CPU. Once the job is done, then we have a table that is present in the memory known as interrupt vector table. This interrupt vector table contains two columns. So first column will be the interrupt number. The second column will be the starting address of the interrupt service routine. Each and every interrupt will have a different service routine. That's why it will have two columns. One is nothing but the interrupt type and its number. It will have the number of the interrupt type, the corresponding starting address of the interrupt service routine. So now CPU, after identifying what kind of interrupt and the associated interrupt number for try to locate where the exact interrupt number is there in the IVT table. Once it has located the IVT once it has located the vector interrupt number which has occurred in the table, it will go to the starting address of the service routine. So now we got the starting address of the service routine. So now the control will be handed over from the CPU to the interrupt service routine starting address. So now what will happen? The interrupt service routine will get executed. Okay. And once the interrupt service routine has completed, then the control will be again given to the program which has been passed. Why the program has been passed? Because of the occurrence of the interrupt, the program's execution was stopped. Now again the control will be handed over to the program which is stopped, and it will start running the program which has been passed by the occurrence of an interrupt. Until then it is clear?
Yes, sir.
Yes, sir.
Hello class?
Yes, sir.
Okay.
Yes, sir.
One more point I'd like to stress here is that after one interrupt has been executed, after imagine that one interrupt has been executed, CPU will also check if there is any other interrupt which is pending. Okay. If there is no interrupt pending, the control will be handed to the program for execution. Okay. If there are some other interrupt which is pending, then CPU will check among the available interrupt, which is the interrupt having the higher priority, because some of the interrupt may be of higher priority. Higher priority means the interrupt which need immediate attention, so that will be given a higher priority. So CPU will check if there is any other interrupt which is waiting in the queue. If no other interrupt, then the control will be handed over to the program which is under execution. If there is an interrupt among the available interrupt, CPU will check which interrupt has the highest priority. Whichever interrupt has the highest priority, then the program will be, then the control will be handed to that interrupt which is having the higher priority. Once CPU makes sure that none of the interrupt is pending, then only it will hand over the control to the program which is under execution. It is clear now?
Yes, sir.
Yes. Any doubts?
Sir.
No, sir.
No doubt, sir.
It's a very important concept. The next one. Types of interrupts. Types of interrupts. Types of interrupts. There are two main types. There are two main types A. Maskable interrupts. There are two main types. There is markable interrupt. Another is non-maskable interrupt. Maskable interrupt. Another is non-maskable interrupt. Maskable interrupts. Maskable interrupts. Whenever maskable interrupt is generated, whenever the maskable interrupt is generated in the system, do you all hear me?
Yes, sir.
Okay, whenever the maskable interrupt is generated, the system may or may not pay immediate attention. Whenever maskable interrupt is generated, the system may or may not pay immediate attention. Next side heading is non-maskable interrupt. Non-maskable interrupt. Whenever non-maskable interrupt is generated, whenever non-maskable interrupt is generated, whenever non-maskable interrupt is generated, the system is bound to pay attention. The system is bound to pay attention. System is bound to pay the attention to the interrupt. The system is bound to pay the attention to the interrupt. Example, hardware error. Example, the hardware error. Example, the hardware error. Okay, now we have discussed about the interrupt. So now can I ask you a question? What are the performance overhead that is interrupt brings? Can you please share, think and tell me? What are the performance overhead of the interrupt? What are the performance overhead of the occurrence of an interrupt? What is performance overhead? Tell me. Anyone know what is the performance overhead? Class?
No, sir.
Okay.
What is the performance overhead of this interrupt?
No.
Class?
Don't know, sir.
Huh? Think and tell me. This is a question you have to think and tell me. What is the performance overhead? Performance overhead is simply nothing but what are the extra things that you have to do? That is called performance overhead. Apart from the regular routine, what are the extra things you have to do? That is called performance overhead. So on occurrence of this interrupt, think and tell me what are the performance overhead of this interrupt. Think. It will take some time, maybe 2 to 3 minutes. I'll give you time, but you have to think. Unless otherwise you think, you cannot develop the knowledge, and unless otherwise you ask the question why, then there is no point in reading these things. Think and tell me what are the performance overhead on occurrence of an interrupt.
Sir, one thing
Don't
is
search
like
in internet. Again, please, I'm telling you, don't search in internet. You have to think from the concept which you discussed. You have to think and ask me the question. Yeah, tell me.
one thing is like when there are many interrupts coming up, will be like jamming. So we have to set the priority.
So what happens when many interrupts coming up? What will happen?
Traffic or jamming will happen. So we have to give the priority queue.
That I already said, na?
But
Okay,
it
you
is,
mean you are trying that when there is too many interrupts is there, then the CPU will be busy in processing interrupt rather than the original program. That is what our intention.
yes, sir.
Okay. So what the VST point is that I said that when CPU, when completing its one interrupt, before handing over the control to the program which is halted, it will check in the interrupt queue is there any interrupt is bending. If there is some interrupt bending, then it will try to sort out that interrupt by giving the control again back to the interrupt. If there are more than one interrupt that is waiting in the queue, then it will always check its priority. Whichever interrupt having higher priority, then it will hand over the control to that interrupt which is having higher priority. If there is no other interrupt which is waiting in the interrupt queue, then it will hand over the control to the program which has been halted its execution. What Divesh is saying that, imagine that if the interrupt queue is very long and there are so many interrupts to be addressed, and the CPU now control is given from the CPU to the interrupt which has been disturbed. So interrupt service routine will complete its job and will look into the interrupt queue. Now there are 10 interrupts. What will happen now? The CPU will be busy processing only in the interrupt. It will not go back to the original program which you want to get executed. So this is the problem that DBSC is saying. I do agree. So she is saying that there will be a lot of process in the interrupt queue, then it will be a big problem. That is what her concern. Yeah, I do agree. What are the other points that others want to make? What are the overhead that we are facing when on occurrence of an interrupt? Please. Others?
Sir, if there are 2 or more interrupts, having,
Little bit louder, Kaushik.
if there comes 2 or more interrupts having the same priority, then there should be some criteria to select a appropriate interrupt.
Exactly, that we have some criteria that if there is a tie in the interrupt priority, then there is a mechanism. I do agree. I just want a different point of view. That's a good point. Any other overhead of this interrupt? Think I'm just expecting a very important point from you. Sriram SG. Tell me what are the performance overhead of an occurrence of an interrupt?
Sir.
Yeah.
How about storage, sir? Storage also has some problems.
What storage?
Kind of, if we have many interrupts, the CPU should handle this multitasking process. That is
You
also
should handle what?
multitasking. Like they have to take the interrupt, it has to go again and give the.
That's a general routine. That is not botheration. That only thing is that if you have a single process system, the CPU can execute only one process at a time. That's all. That's a general routine, right? What is the overhead there?
Just thinking, sir, like multiprocessing should be.
No. Talk about the single process. I'm talking about the single process. So if you're not getting, I'll just say the CPU or this interrupt, occurrence of an interrupt will cost us. Why? Because imagine that you are executing a program and you are executing the fifth line, somewhere the interrupt occurs. So what you have to do, you have to save in which line on execution the system interrupt has occurred. Because you have to resume from the same line. For example, if the interrupt occurred while executing the fifth line. So what will happen? The fifth line will not get executed. Immediately the control will be given back to the interrupt. The interrupt service routine on complete its execution, it will check the interrupt queue. If there is no other interrupt, again the control has to be brought back to the same line where the execution has stopped. Do you agree with me?
Yes, sir.
Yes, sir.
So somewhere it has to save where the program in execution has been stopped due to the occurrence of an interrupt. It has to save where the program which is under execution has been stopped due to the occurrence of an interrupt. And also you should save the program status. So once the process is started in execution, the process state will be in the execution run state. Once it has been stopped, we have to change the status of the program which is under execution from the run status to halt status, and then we have to save at what line it has stopped its execution. That is very, very important, because once the control has been given back to the program, it has to start only from the place from which it has been left. It should not start from the beginning. So the first overhead will be the cost of storing and restoring the process state. Second one, the cost of, I will just dictate the notes later. First we will discuss, then I will discuss the notes. The second one will be the cost of flushing the interrupt pipeline. I said that if there are more than 2 interrupts, the interrupt on the control after executing the first interrupt, it will check whether is there any interrupt in the interrupt pipeline. If there is any interrupt pipeline, then it has to hand over the control to the interrupt which is waiting in the pipeline, not through the program. After executing the interrupt, it has to clear the interrupt pipeline. So that is also one cost to overhead. The third overhead would be like restoring the instruction into the pipeline when the process is restarted. So these are the 3 overhead of an occurrence of an interrupt. Please write performance overhead of an interrupt. Performance overhead of an interrupt. The first one, cost of storing and restoring process states. Cost of storing and restoring process states. Do you all hear me?
Yes, sir.
Okay,
Yes, sir.
cost of storing and restoring process states. Second one is that cost of flushing the interrupt pipeline. Cost of flushing the interrupt pipeline. Third one will be restoring the instruction into the pipeline. Restoring the instructions. No, the third one will be restoring the instructions. Third one is that restoring the instruction, not in the pipeline, redraft it. Restoring the instruction when the process is restarted. Restoring the instruction when the process is restarted. Restoring the instruction when the process is restarted. These 3 are the performance overhead of an occurrence of an interrupt. Okay, do you all agree? Do you are able to get the concept?
Yes, sir.
Okay, now I will give you the interrupt driven life cycle. Okay, please draw this diagram. Please draw this diagram.
So the screen is not shared.
Can you able to draw this diagram?
So screen is not shared.
Oh yeah, please wait. Please wait. Can you able to see the screen now?
Yes, sir.
Okay, please draw this diagram. Interrupt driven cycle. So first was that please draw. I have marked in sequence the device driver initialize IO,
then initiate IO. Please draw the cycle. Have I drawn this diagram?
Sir, drawings.
Please draw. The left hand side is nothing but a CPU. I'll just explain. And once this interrupt occurs, what will happen? It will initialize this second step. It will initialize this input-output operation. The control from the CPU will go back to the interrupt. So once the control is transferred, it will initialize the input-output. And once the input-output has been done, completed, then again the control should be given back to the CPU. CPU receiving this input, again transfer the controls to the input handler. So input handler processes data, returns from the input, and CPU resumes processing of the interrupted task. Please write all the 6 steps. We will discuss that detail in the next week. Have you drawn?
Yes,
Yes,
sir.
sir.
All of you drawn? Okay. So now this week I have already transferred the placement group, and I have the DVST has given the schedule for aptitude, and Hari has transferred the topics for this technical session. So this week group 1 I assigned for aptitude, and group 2 I assigned for technical. Any doubts in that? Who is there in the group 1?
Sir, me, sir. Me and Ajani, sir.
You and Ajani. You were in which group, Hari Krishna?
Group 1, sir.
Group 1. So you'll be looking care of aptitude?
Yes, sir. Sir, shall we select any one of the topics, sir?
No. You cannot select any one of the topic. You have to select the first topic. Otherwise, it will be random. You have to go in sequence.
Okay, sir. We choose the first one.
Who is in charge of group 2?
Sir, me and Sivalila.
Juhirani, please. What topic are we going to discuss? Please go through the topic which is shared by Hari Krishna, and make sure
Sir,
that
but technical is so vast, sir.
we have to do it. No other way.
Can't we divide the parts, sir, in that also?
That we will see. That is left to the group actually.
Okay, sir.
So this week we have to start, and the placement session is scheduled from 2 to 5. So make sure that it should be like this. You have to discuss what are the general aspects involved in the topic. You have to solve some samples. Then you have to prepare some 10 questions with that topic, and you have to post it. So everyone will utilize that placement hour in solving that problem which has been posted. Okay. So you have to prepare in those lines. Is it okay?
Yes, sir.
Okay, sir.
Okay then. So have we drawn this interrupt driven? We will discuss that in the next week class. So we'll meet again on Saturday afternoon. Thank you so much. Give the attendance.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you, sir.